hello. Hi everyone, can you hear me?
Yeah, just go.
All right, fantastic. Well, welcome you all to our talk, right? This is a talk from NVIDIA. It's a pleasure to have all of you here listening to what we have to share with you today. If you're not familiar with the NVIDIA platform on Google Cloud, we cover a lot of workloads, from AI training to AI inference, graphics, visualization, HPC, high performance computing, across several industries, right? From healthcare to manufacturing to oil and gas. So for me, before I start any of these talks, I like to find out who's in the audience and understand, just make sure I'm spending time on the right pieces of the presentation so you're getting, your time's worth. So I'll ask that, maybe 3 or 4 volunteers just really quickly say the name of your company and perhaps, what you run with GPU. So I'm sorry I'm picking on you over here. Can you please, yes, you.
I work for Landing Point, and actually we just transferred in Google on the machine learning section, so we'll need the GPU just to do trainings on it.
Wonderful, so that's training, machine learning. Anyone here doing HPC, high performance computing? Yes? If you don't mind, what industry?
In healthcare, Moffitt Cancer Center, Tampa, Florida, we do, our research arm does HPC research in genomic data sequencing plus radiomics for AI, ML.
Fantastic, that's great. All right, so I have things to cover on AI training and healthcare, so that's pretty good. I planted them in the crowd, by the way, so that, it'll be covered. So on this talk, we're going to be talking about, just how do we get you to get the most out of your GPUs on Google Cloud. I didn't introduce myself, so I'm Alex Tsado. I'm actually part of the product team at NVIDIA. Pretty much I lead our product marketing team as it relates to Google Cloud. And what that means really is it's my job to pay attention to our users, people who use our platform on GCP, ensure that they're having no issues, ensure they're getting the most out of their GPUs and making that work. So if by the end of this you have any questions, please let me know. Don't talk to my boss, let me know and we'll figure it out, all right? So to provide, as far as overviews go, to provide some context before we start talking about what you get out of GPU, how you can get the most out of GPUs on Google Cloud, we'll start with giving you a little overview of our platform, talking a little bit about our partnership with Google Cloud, and then talking a little bit as well about what's new on that platform, and then the meat of this presentation, which is how do you get the most out of GPUs on Google Cloud. Then we'll end with some case studies and we can go have some party with the music. I know some people have started to hear that already. Well, I do like to start with this slide. It's a pretty interesting one. It's the Moore's Law slide, right? It's talking about the end of Moore's Law. What that really is speaking to is how do I call this? The starvation of compute that scientists face, right? With Moore's Law, what that really tries to show is that, more or less every 1.5 years since the early 90s, researchers, innovators around the world, every 1.5 years, they start to require twice as much compute to solve more interesting, more complex problems. CPUs, single-threaded computing, has been trending with that line pretty fine up until the late 2000s when it started to taper off, right? From that point, you needed to switch to parallel computing, which NVIDIA GPUs pioneered to get to meet up with the compute that you need to work on state-of-the-art solutions. So that's what's necessitating NVIDIA GPUs. And to meet that need, what's actually happened is we are providing this entire platform. Many people here, I imagine, are very familiar with the GPUs that we provide, the piece of hardware. But beyond those is actually the entire stack on top of the hardware, right? So it's talking about the SDKs, which we call CUDA right now. They're all built on top of CUDA. Software SDKs and libraries across board for machine learning, deep learning, high performance computing, as I mentioned earlier on, and accelerating frameworks and applications across domains. So you're working with the same platform, but getting the acceleration across board. And then we'll work with our partners like Google Cloud to provide, solutions across a vertical chain. That's actually a pretty nice segue to, talking about a partnership with Google. So with Google Cloud, I see a few of my partners over in the audience. When I chat with them, what we say is we think of this concept of Einsteins, aspiring Einsteins. There was a time where you needed to be part of the top 10 companies, the biggest companies in the world, to get access to the kind of power, compute power, and infrastructure you needed to work on state-of-the-art solutions. With the cloud, with Google Cloud, it's about democratizing that power and providing you with a platform where you can get Einsteins. Einsteins can come from anywhere in the world, right? This is what Google Cloud provides, especially as they provision NVIDIA product on their cloud. I'm choosing to highlight just 4 parts of our partnership so far. On the first box there is talking about the broadest array of GPUs, from K80s to V100s and T4s, which they announced last October, I believe. You have GPUs for all the workloads you can think about in accelerated computing, from high performance computing to AI training, inference, and machine learning. On the second box there, we're talking about training and inference. We do a lot of software work, software integration, software partnerships with the Google engineering team. Specifically in that scenario is with the TensorFlow team, where we've worked with them to integrate our software products like TensorRT and automatic means precision to provide you with 3 times more performance when you're talking about AI training and AI inference. I mean, said differently, 3x, right? This is, you're spending, if you're not using these software optimizations on Google Cloud, you are spending 3 times more money than you need to. I mean, it's a no-brainer. You should figure out how you can get some of those benefits, and that's why we're here talking about this today. And the last 2 boxes here, talking about how NVIDIA GPUs are integrated to the rest of the Google platform in terms of Kubeflow for inference deployment, Zinc for rendering, Google Kubernetes engine, and the rest. The last box is speaking about workstation graphics. I mean, I don't know, do we have any graphics professionals in the crowd? Any folks who are doing any graphic visualization, especially on Google Cloud? Please, there's one. All right, I guess it's just one. So everyone else, you could probably close your eyes. He's the only one who benefit from the rest of this. I've got a little video here I would like to show. It's 1 minute long, but it speaks to you about a pretty cool announcement we just made on Google Cloud less than 2 weeks ago. Let me blow this up. Alright, so what this is showing is virtual workstations. We now have a Quadra virtual workstation available on Google Marketplace. With that, you're able to do RTX, you're able to leverage ray tracing cores on our new Tesla T4 GPUs to do graphic, to work on graphic scenes. This is, for example, I believe is the Autodesk Maya application. When movies are designed, you work with applications like this to put together your graphics, and what you find is, historically in the past, when you move your mouse, you have to wait a number of seconds before it moves. People are nodding their heads here. It's extremely frustrating. It's really, really difficult to do. But with this new workstations, which you now have on the cloud, you're able to do that in just a few seconds. It's actually pretty much real time. I'll blow this back up here and take you over to that slide. So that is actually a pretty monumental announcement for us, because I mean, I don't know if you've been paying attention to these trends, but over the past 10 years, every single movie that was nominated for Best Picture at the Golden Globes was actually running on NVIDIA GPUs, and now you get that same power on Google Cloud. Like, imagine what you can do with that. That's just truly phenomenal and fantastic. And then one other benefit I'll speak about is like with workstations. Before these workstations were available on the cloud like Google Cloud, you would have to have one graphic designer working with one workstation in his office, and it would be very difficult to collaborate with other, professionals in regional offices or global offices. But now with the presence of this on the cloud, you're able to scale across teams and, multiply the kind of innovation and collaboration you can get out of that process. So the call to action here is, if this is part of your work, go on Marketplace and pick it up. So now to more of the meat of the conversation, talking about how do you get more out of GPUs on Google Cloud. One of the very first ways is NGC. If you're not familiar with NGC yet, NGC is pretty much, think of it like the App Store, right? From NGC, you get every piece of NVIDIA acceleration software. NGC is accessible through Google Launcher. I have a link down here. You go on there, you search NGC. From there, you get access to over 60 containers, right? Talking about deep learning, machine learning, HPC, model training scripts, industry workflows. You can pick all of those. And I mean, if you're talking about the benefits of NGC, I like to say NGC saves lives. And I'll explain why. I mean, what we see from surveys that we've sent out to people is that for some of your best engineers, they spend anywhere from a whole day to a week trying to put together all the software they need, all the right versions they need to achieve the best performance. But then when you leverage containers like we have with NGC, you're able to get up and running in 3 to 5 minutes. I mean, we have these demos at our booth all the way on the end. I believe it's 121209. You can go and see that demo on how you can get started in less than 5 minutes. And that is, just truly transformational for how engineers can get up and running. This is another new announcement. It's talking about model scripts that are now available on NGC as well. At our GTC, which was more or less 2 weeks ago, we announced 14 new optimized containers for deep learning. You can think of them as, examples that you can pick up and build on top of. It's more or less like, building on the shoulder of giants, I believe is what they say. And so some of the examples are, I don't have that listed on here, but pretty much these are updated every month. So you're constantly getting the best of these examples and you can build on top of them. This one I'm actually pretty excited about is Tensor Cores. So Tensor Cores are parts of our new GPUs, the V100s and the T4s. These cores provide you up to 3x speed up on training and 4x speed up on inference. If you're not using these Tensor Cores, you're not getting the most out of these GPUs you're paying all this money for. You're leaving a lot of performance on the table. You're leaving a lot of money on the table. You need to get and learn how to use Tensor Cores. We run surveys to find out some of the top reasons why people aren't using Tensor Cores, and 2 of the top ones are, first and foremost, it's pretty difficult to get it up and running, right? I didn't know that, it's pretty hard. The second one is there's a concern that if you're running mixed precision, you will lose some, quality in your in the results you're able to get. And so we went back to our engineers and we decided to work on that and figure out what we can do for you. So in terms of the first issue of being difficult, we're able to reduce everything down to 2 lines of code. I think that's what it says over there, 3x with 2 lines of code. I mean, that actually depends on what framework you're using. If you're using TensorFlow, it's actually just 1 line of code. Like, I mean, how difficult is it to say export TF underscore enable underscore all? It's actually hard to say. Underscore mix underscore precision equals 1. But it's easy to copy and paste that. And with that, you enable Tensor Cores and you're getting 3 times more performance. We've put together a lot of assets to help you get through this in terms of a whole web page to get you through the journey. GitHub, I believe I see some GitHub folks in the crowd. We have some GitHub where you can pull some of this code, and obviously NGC keeps coming back up. Everything is on NGC, so you need to pick up all of this from NGC. And it supports TensorFlow, it's integrated with TensorFlow, PyTorch, and MXNet. Addressing the whole comment on accuracy and quality, these are some of our partners and what they're saying about this, right? So, I mean, it's pretty long, I'm not going to read everything, but the first comment is from the engineering director of TensorFlow at Google, and the second one is from the senior director at Alibaba. So, like the end of this comment, you can see you're getting 3x higher performance while maintaining model accuracy. And in terms of some proof, this is what some of our customers have been able to share with us, what some of our users have been able to share with us. This is across networks. This line is for FP32 and mixed precision. You can see there's the same level across board. You're not losing any of that. And this is what we're able to get. This is what our customers have been able to share with us. If you're getting anything different, which is possible, let us know. Just reach out and we'll work on that together and see if there's actually an issue there, or we can work at something. And so to start rounding up the talk, I will share with you some customer, some case studies on some customers who are already getting transformational value on Google Cloud. So the first one is, this is a speech example, speech AI, and the second one is a HPC example. It's oil and gas, in the oil and gas space. But the first one is by a company called Babu Labs. They're a pretty well-funded startup out of Stanford, well-funded by ex-Yahoo money, and they're solving a very difficult problem. I mean, I have an electrical engineering background from many years ago, and I did digital signal processing, so I'm pretty familiar with how difficult it is to clean up noise. I mean, I don't know if there are any other DSP people in the crowd who have gone through some of this, but a very easy example of this is with your Alexa tool or your Google Home. When you're speaking in a noisy background, the level of error, the error rate is pretty high. It's really difficult. So it's really important that you're able to denoise, take out the noise from the sound so you get something clean and you can, accurately predict what is on there. So Babu Labs was able to do something that was never possible before until they started using GPUs. They were able to process loads and lots of speech data and train their model such that now with their Clear Cloud application on Google, your App Store, you can search it. It's called Clear, C-L-E-A-R. It's a pretty fantastic application which developers in the crowd, you can download that API, and with that you can clean the noisiest of data. Like right now, if we were to record this, I'm literally going to go clean this with Claire. After this, I'm going to go clean out the music that was happening, and I have a very clean, pure, stream of sound. That's what Babu Labs was able to do. For the second example, Schlumberger, pretty familiar name in the oil and gas space. With these oil companies, what they do, well, in this scenario with seismic simulation, they take subsurface view of the entire ocean and figure out where the oil is, right? They try and profile what's on there, because and then after they finish doing the profiling, they deploy and get, try and go extract that oil. Very, very expensive, if they make any mistakes in this profiling, it can cost them millions and millions and millions of dollars. So it's an extremely important process, and also an extremely difficult process because these images are really large. With GPUs, they were able to process petabytes of data and provide that image you see, which is actually done with another NVIDIA product called Index, to visualize that piece. They're able to process all that data and characterize the oil surface accurately to enable them save millions and millions of dollars. I mean, that's the kind of acceleration you get with the NVIDIA platform. It accelerates your time to solution. It allows you to iterate faster to your solution, so you're learning from your mistakes really fast before you actually go and deploy your dollars. And with that, I would probably start wrapping up now. Just reiterate some of the key takeaways from this. Extremely important in terms of technology is talking about, the virtual workstations are now available on GCP via App Marketplace. You can go and download it and start building world-class movies that will win the Grammys. You can do that now on the cloud for the price of coffee, $25. There is a tight software integration with the Google platform. When you talk about NVIDIA on Google, you're not just talking about hardware, you're talking about integrations with TensorFlow, with Kubernetes, and all the other open source software on there. And you can get all of that for free on NGC. I don't believe I mentioned that earlier on. NGC is free. Everything on there is free. You can go pull the software and start working with it today. And then finally on the side of technology is AMP/TF. Automatic mixed precision is now integrated with TensorFlow. Go get your 3x improvement with one line of code, right? And if this doesn't work, ask us questions. You can talk to me here, you can talk to some of my colleagues in the back, and you can talk to us at our booth. And with that, that's the last of my comment. If you have, you can ask me any questions, but otherwise, that's it. Thank you. Any questions before we run? There's one here.
How do we actually turn on the TensorFlow feature? So we have some GPUs running for AI prediction since October. And do we need to update a daemon driver or something?
So pretty much it's code. You have to make some changes in the code. To turn on the mixed precision is pretty much going from whatever precision you're on right now, probably FP32 to FP16, and working with that multi-precision. With the piece of code I just provided, there's more on the TensorFlow. I can go back to that. On the TensorFlow page, you get all the instructions on, depending on your framework, you see what code you need to, what lines you need to include to get the access there. Yep.
Will that also change, like when we have to say from GPU, CPU, change our data type? So it is going to change the data type as well?
Tensor cores, right? No change to your data type. It's going to remain the same thing, and you're going to get 3 times more performance. It's extremely fantastic. All right, I believe that's the last one. Thank you, everyone. Enjoy the rest of your evening.